Thank you. You are now being joined to your conference.
Industry, we found that clean in place process was the second largest user of energy after pasteurization, and one intervention that could reduce this was ice pigging. Now, we trialed ice pigging in two dairies. One was Yo Valley, and Annie will talk about that shortly, and BV Dairy as well. But we also think that ice pigging could have applications across a range of industries and not just dairy. So the trials are funded, as I said before, by the UK government through the Regional Growth Fund. And the Carbon Trust role so far has been to support those projects and to disseminate any knowledge that came out of it, and that's what this webinar is in aid of today. So I'm going to hand over now to Joe, who's going to talk you through the ice pigging process. Over to you, Joe.
Thank you. I'm very excited about the ice pig. I think it really does represent a paradigm shift, and the video will give you an idea of why I'm so excited. So this was done about a couple of years ago, and it shows us trying to pig yogurt. We ended up buying some yogurt from a major, well, you can sort of see Asda, a major supermarket. It was the cheapest yogurt we could get hold of, and we coloured it because ice seems to have the same colour as yogurt. We put some red colour dye in, but as best we could tell, the rheology and the properties of the yogurt won't change because of our dyeing. We're an engineering lab, so we didn't have pipes and pipes full of yogurt. So we bought about 10 litres worth. And you'll see the rig in a minute, but we filled a pipe, a 3-inch diameter pipe, the pipe at the very bottom that you can see. And there's about 2 and a bit metres, 2 metres straight, and by the time you take the edges in, about 2.5 metre length of 3-inch diameter pipe is filled with the yogurt that you saw being stirred. It takes a bit of time, but we just fill that pipe. So it's not really representative of what happens in a dairy factory, because it's being filled and then we sort of go off and think about the next stage. So it's sort of stagnant, and perhaps we're getting some setting or whatever. But we fill the pipe, and now we're releasing the ice pig. The ice pig is going through. The picture at the very top, the small picture on the left-hand side, is the exciting bit of what's happening throughout the picture. So you can just about see pinkness, that's the yogurt. Behind it is whiteness, that's the ice slurry, the ice pig. And you can sort of get the feel that, my God, there's a bit of breakthrough. But those of you in the dairy industry know about ratting and white water, lakes of the stuff. This is really very sharp, as we'll see in about 3 or 4 minutes' time. The speed at which the pig is going through has not been optimized. It's just the pumps that we had available in the university. So it's very dependent on what we could do. And we're an engineering lab rather than a food factory. We attempted to put lots of bends in there, so 90-degree bends, from 3-inch to 2-inch to 1-inch to splits, back to 2-inch. There's even an orifice plate from a 2-inch through a 1-inch orifice plate. So the topology, the geometry, is as complex as it gets. We've now feel that we've put enough ice in, we think we've cleaned it, and we're going to chase the ice with water. So the thing is now stationary. We're finding out where the valves for the water are, and this is just mains water. And again, the flow rate is set by our mains pressure and the pipes leading to it. So it's now water pushing the pig. Water is the propellant. And you'll see that the space between ice and water is very sharp. There it is, coming round. There's a slight mistiness about it. That's condensation on the outside of the pipe. The pig runs at about, I don't know, -3, -4 degrees C. It can't get much sharper than that. That is gorgeous. I have to tell the truth. There is some percolation of water through the pig, but it's minor. So the thing keeps on pushing. I suspect we've got some computational CPU issues. The video should run all the way through. I'm sure it will do in a few minutes' time. The pig keeps going because the water's pushing it through. The sharpness is, I think, orgasmic. I mean, you aren't going to get anything sharper than that, really. And that's 3-inch going down to bends, going to 2-inch, and so it's a bend, another bend, and now it's entering a 2-inch pipe. At that point now, it's gone through an orifice plate. Again, no problems. Interesting, this split, and there is more resistance in one than the other, so it prefers the least resistance, but actually the other one also gets cleared out. That is, I think, magnificent. What is being offered with the pig is all problems to do with topology have been solved. We can actually go through 1/2-inch millimetre holes if we prepare the pig correctly. And the biggest pipes we've done with are getting on for, I don't know, 1/2 metre diameter. So topology's gone. We've now gone to have a look at what happens at the outlet. So the pig's going through and it's displacing pure quality yogurt. That's product that can be sold on to the customer. It now stops, and the reason why it stops is the period where we sort of thought about it, we need to push it with water. So we had that little delay period, and now we've found where the water is, and more comes through. And this is still high-quality yogurt with no contamination at all. By the time we get to the 3rd bucket, we are getting minor breakthrough of ice through the yogurt, and now the 4th one, it's rubbish. You really will have to effluent treat it. And you can see that the pig coming through. But it is now just pure pig coming through. No more yogurt. We'll have a look at them again, and 2 beakers full of pure yogurt being recovered, a beaker full where you're going to have to do something about effluent treatment, and then the rest is just pretty clean ice. And that's the water that was chasing the ice pig. So the first 2 buckets, pure yogurt that can be sold on to the punter, to the customer. 3rd one, you're going to have to do something about it. 4th one, you're also going to have to do something about it, really. But it's nice cold stuff, so the effluent people will love you because it's nice and cold. And the kit looks immaculately clean. I stress looks clean. It clearly isn't biologically clean. You're still going to have to do a CIP if you're interested in getting everything out. But the CIP time will be as nothing. You're not eating away soil, just looking at minor traces. There doesn't seem to be any cracks or gaps where the pig gets stuck. So reasonably small volume of ice pig required to clean that pipe. I realise in factories the pipes are longer, more complex, but it's not an unreasonable representation. So this is for me as well to harp on about how great it is to do the sales bit. And academics are dreadful salespeople. The first one, reduced downtime, it is the ultimate. Whenever we do the sums, that's what the factory people go for. If you're using your factory 27, ice pigging reduces the CIP time from, I don't know, 35 minutes down to 15. The hot caustic flush goes to nothing because you've removed most of the stuff. Of course you get product recovery, you saw that. The other thing about product recovery, if you've got products which are similar but you'd like to separate them, and there's no need to go hygienically clean, you can have a sterile pig in between product A and product B, throw the pig away and a bit of product A and a bit of product B, and then you're straight into product B. So product recovery and reduced downtime if it's just a changeover. Because you've removed the soil, you aren't going to use very much sodium hydroxide. Both acid and alkali are going to be reduced, and that's reduction in cost, but also reduction in nasty stuff that you're throwing away. Less chlorine, less everything, less BOD, less everything. The last point is energy saving. I think when I do the sums, I think we do get some energy saving, but the biggest hit, and this is bad because this is carbon trust, but the biggest hit will be reduced downtime. So if you're, I don't know, Arla or Muller or whoever, and you need to build another factory, if you've got 12 or 15 factories, put the pig in all of them. You don't need the 16th factory. I reckon that's the sort of downtime reduction you'll get. I think worth a lot. Right, that's it.
Fantastic. Thanks a lot, Joe. That was really interesting. I never tire of that video. So I'd like to now ask Andy, please would you talk us through your Yarra Valley facility?
Good morning, everybody. What we did some trials back in November 2012 down at our Newton Abbot site, and we chose a pilot plant that we've got installed down there so that we didn't impact onto our main processing, and we could carry out some quite specific trials. We carried out 7 trials in total using this plant. You can see a cook vessel, a pump, through a strainer, which we'll talk about going through, a couple of heat exchangers, scrape surface heat exchanger, and then through 2-inch dairy pipe downstairs to level 1 ground floor, where we have our packing facility in the collection vessel. So you can see the temperatures, diameter, pipework, length, pipeworks, and the volume. And what we were doing, this process uses about 500 kilos in the cook vessel. We then cook this up to the 86 degrees and then send it through the process. But we do have high wastages on this line. We go into a bit of that detail as we go through. We normally chase it through, once we've pumped most of the product through the 500 batch, about 30 kilos of water dropped into the cook vessel so that we can recover some of the product. But as we all know, that as soon as you have a water interface, then you start to have a long prolonged discharge out and you don't recover all of the product. So that was the process plant we used. If you go on to the next. So water-based flushing phase. So once we've cooled through the rotator heat exchanger is complete, the line remains full of product, which as I say is 83 litres. We add 30 litres of water through it to try and push through, which then remains 53 litres of product in the line that's unrecoverable. We then have to flush all that product through before we would then go on to another product. So when you're using a chocolate surprise type product through there, it does stick to the pipeworks, and the flush is considerable and to drain as well. So very high volumes, very low recovery of any of that going through. Lots of the trials we carried out 7 trials in total, and at various stages through this. And I think this is where Joe jumps back in a little bit if he wants to contribute. So the ice pigging equipment was, the biggest problem we had first of all was that when it was brought down to us, we were talking in the other industries, they were using salt as a medium for the freezing point depressant. Obviously our industry, we didn't want to use salt, so we had to then work with the team to use a sugar solution, and it ended up being about a 10% to 12.5% sugar solution within it to achieve the freezing point depressant of about 75 to 80%. This was achieved most of the time, so there was a couple of trials we did where we didn't make enough ice at the time through one reason or another. So the trials we wanted to do, we started right the way through the whole process, and if you remember the process from the cook vessel all the way through. Now we find that the strainer that we had in line dewatered the ice, so that we have a 1.5 mil strainer in line, and that was a problem. So the first trial was cancelled because of that. So we then moved down through the system to the rotators. And again, there were some problems there because obviously the heat transfer in that size of it, so you know the ice pig that we would have to make there was quite substantial. So to carry on with the trials, we then moved to the furthest end of the process flow to purge through the pipework. And that's some very, very good success rate doing that. And then we worked back after we proved that we could use the system successfully and it did what it was supposed to do, and then worked back through the rotators, and then we did an ice pig injection for the entire system, but removing the strainer through it as well. So on to the next one, I think. So this then shows some of the photographs, and it backs up what Joe had showed you just now on the video. So as I said, we did 7 trials in total. The 7th trial tested the whole of the system, and if you look at picture A, this is downstairs in our high care facility. So you'll see the pink, which Joe had highlighted on his video as well, which was our product. You can see the ice coming out, and the most stark thing for us on the site was how quickly and clean that pipework become with the water interface behind it. So as soon as we had purged it through with the ice, then the product recovery was great, proved that, and we wouldn't have had to then flush through those lines to move on to our next product at all. We didn't run it on more complex plants at the time, and I think that's definitely something that we would have liked to have carried on with, to see how it would then go through more complex valve matrices and things like that. But definitely proved the point. and had some very successful trials carried out towards the end.
Great, thanks a lot, Andy. Joe, is there anything you'd like to add to that?
No, Andy's done a super job, but please have a look at picture C, and the sharpness is just, well, out of this world. You know, if that were water, it would be all over the place. Andy's done a super job. We use sugar because that was what we thought we could get away with. Other people, say in the drinks industry, would prefer to use things like citric acid. Perhaps for creams, dextrose might be a better freezing point depressant. We do need a freezing point depressant in the system. Salt's very good because it's ionic, and for certainly the savoury stuff, so for the sausage meats end, we'd probably want to use salt, stay with salt. For the drinks, the beers, the milks, it may be a sugar, or it might even be a citric acid if it's a fizzy type drink. That's all. Thank you.
Wonderful, thanks, Joe. So, following the trials, the Carbon Trust have been carrying out some desk analysis to try and figure out what the impact of ice pigging could be. Now, this is, as I should make very clear, preliminary desk research, and more trials would be very welcome. But based on some data around a representative bakery influenced by Andy's input, we have come up with two scenarios for how ice pigging could be implemented in a dairy, which would save a typical site between 130,000 and 360,000 pounds a year, depending on the scenario. Now, let me tell you where that comes from. The first scenario, the standalone scenario, is very much like the one you saw in the trial there, where you have equipment that is moved around ad hoc and used as necessary. It's not integrated, essentially. So under this scenario, we assume that product can be recovered, as demonstrated in the photos and the video, but given the complexity in fitting the moving ice pigging equipment to the lines, there's no value from reducing downtime because that time is taken up attaching all the gear. Now, there are a range of assumptions which will be made public in a case study we're releasing in a couple of weeks' time, but the key ones here are the capital cost of the ice pigging equipment is around £250,000. That is based off more like R&D type equipment, and we're hoping the cost will come down, of course. But even with that kind of cost and reasonable product recovery and product value, we would expect significant benefits and payback periods within about a year for that system. Now, the second one, the integrated situation, is further down the line and hasn't been tested yet, but this assumes that ice pigging is fully integrated with a facility. So the way I would imagine this is having a centralized ice pig producer, pipes that run around the facility, and it can be tapped off as required. Now, under this scenario, you get the same product recovery value because you're recovering the same kind of product, but because the system is fully integrated and you can access the pipe where and when you need it, that would reduce downtime. And if your facility is operating near capacity, that reduced downtime could be turned into production for more solar product. Now, the assumptions behind that, of course, depends on each individual case. Here we assume that all of that downtime can be turned into production, and that would, of course, vary by dairy. But it gives you an interesting range of how much value could be saved by ice pigging. And for clarity, the capex, the capital cost of the integrated scenario is more like £1 million for the equipment in the facility. But again, that is very theoretical since it's not been done. It would be interesting to see where that would go. In terms of next steps for this project, we are, as I said, releasing a case study either next week or the week after, which will be released to the press as well. And we outline everything that you've just seen in much more detail, including the assumptions behind that analysis as well. We also recommend areas for further work. Given the work done so far, we think it's very interesting, but there are certain areas that we weren't able to look into for these trials. So first of these, as the Carbon Trust, we're interested in energy and carbon benefits. Now, Joe alluded to the fact that product recovery and downtime are the most important benefits, but we do also see improved environmental benefits, both from reducing energy and carbon and decreasing biological and chemical waste sent to effluent. We also see value in developing innovative ways of making ice more efficiently to reduce the energy cost of the ice pigging process. As I said, integrating the ice pigging into facilities so that it can be used much more effectively and release more value, and looking into ice pigging in other industries. As I said, so far we've only looked into ice pigging in the dairy industry, and Matt from Ecology will tell you about his experience in the water industry in a minute. But we do see this technology being widely applicable to a very wide range of industries, and we'd like to see work done in that area to see what other industries could benefit from this technology. So on that note, I'll hand over to Matt to talk about his experience at Ecology.
Hello everyone. Yeah, thank you, Michael. So we've been doing ice pigging in the water industry for the last 5 years as a commercial service, and it certainly taught us a lot of things about the way to make sure that ice pigging works extremely well. Who we are, we're a solutions provider primarily for the water industry, but we have salespeople when we work in the industrial sector as well, and we will have had salespeople that have probably come to meet and talk about our solutions to you and your facilities maintenance representatives. So we're active in the UK, we're active in other parts of the world with this solution and others. So what we're trying to do now is to take the experience that we've had with our ice pigging in the water industry and see if we can translate that into other applications. As Michael said, there are a whole range of applications where this would be beneficial. So just a small amount of background about our experience in the water industry. We've cleaned about 700 kilometres of pipe worldwide using ice pigging. If you're anywhere near Bristol, you may have seen our ice tankers driving backwards and forwards. We're quite busy here in the UK serving water companies, the same in Australia, the same in the USA, the same in Japan, in Spain, in France, in Holland. So we feel we've successfully translated this in the water industry from its starting point here in Bristol and our close connections with the University of Bristol. One of the things I've heard and seen is that you know, the business case and the commercial service of ice pigging is something that doesn't exist yet. So as of some point last year, we now have full rights to do ice pigging across all the industries, and we're very, very active now in creating a solution that will work in the food industry. And that solution, we believe, I know Michael gave some ballpark figures for cost of equipment. I think my personal opinion is that those prices are too high to make this work, and so we will bring 5 to 7 years of experience around making it work financially, and developments with equipment that will resolve and certainly have resolved some of the issues seen in the trial that Andy explained. So we're very confident that when it comes to a commercial offer and a commercial solution, we're in a strong position now to make this work, and we're very interested to talk to factories that might have an interesting application that they think ice pigging could work in, but they feel that either it doesn't work financially or they don't know who to speak to. So we're here, we're a UK organisation, we have an international, so we have branches internationally. So if you're an international organisation, we are able to, and we often are, working in different places outside of the UK. So yeah, our hope is that we can provide services, both a service and products, either directly or through licensed partners. And we have a dedicated website, which you can see on the screen there. It's ice-pigging.com. Which will have more information about the other industries that we're providing ice pigging in, which are, if you're interested, it's a fascinating subject. If you care about pipes, you know, if you're boring and you think pipes are exciting like I do, then there's a lot of activity and interesting applications there. So that's just a little bit about Ecology and our position in all of this. If you want to talk to someone about how to do ice pigging, we're here and ready, and we've got lots of people ready to talk to you about that.
That's great. Thanks a lot, Matt. Now that brings us to the end of the content section of the webinar, but we'd like to open up to questions so that you can ask Joe, Andy and Matt anything you'd like to. It's a little bit complicated the way we use WebEx. If you look at the very top of your screen, you should see a pull down bar that has a chat button. If you hit that and let me know that you'd like to ask a question, I've currently muted everyone's microphones to minimize background noise. So let me know who you are and I'll unmute the microphone so you can ask a question. Or if you'd like, you can type me a question and I can read it out for you. So let's wait a minute or two for you to figure that out and send me any questions you'd like. Hi, Hannah and Philip. I'm going to unmute your microphone so you can ask your question. Okay, go ahead.
Hello, this is Philip, Process Improvement Manager from Weissmann's. Can you hear me?
Yes, we can hear you.
Yeah. My question is more about how you control. Is it flow based? Is it you got a density meter in online? How does it work?
I think that's for you, Joe.
Do you want to answer that?
Right. I'm not sure I understand the question, but the ice pig would be inserted wherever you've decided to insert it, and you'd push in whatever volume you thought you wanted. You can detect the pig by a number of different ways. The simplest would be just to look at the temperature on the outside of the pipe, but you know how much volume you've put in. What we're working on in the university is to look at acoustics. They're very, very cheap and very accurate, so we put an acoustic oscillator on the outside of the pipe, so no hygiene issues at all. And we're not trying to measure velocity or anything else. We're just listening to a different characteristic, and the food will always have a different characteristic from the ice. So that's how we're doing it in the university. But I'm not sure that I probably understood the question properly.
Yeah, understood. You understood it correctly. Thank you very much.
Wonderful. Yeah.
I think sorry, in the water industry and what we look at in other applications is using pump speed as a way of measuring how much ice we've put in. It's just fairly straightforward, but you're using particular pump, and the correlation between pump speed and volume of ice inserted should be fairly straightforward to control.
Nice one. Thank you very much. Can I have another question?
Of course.
Have you done any tests in terms of how effective it is with the mix-proof valves and other types of valves?
Can I take that for a little while?
Yeah.
We have and we haven't, in the sense that it's so dependent on the product. So for things like meat slurries, sausage meat, the interface is almost perfect, 90-odd%, 99%. For other materials, like milk, liquid milk, there is more breakthrough. The ice pig is not a solid pig. When you push it with water, water does go through the pig, but only a very small amount, as you saw in the video. So I know I'm going to be hit by everyone by saying how bad the pig is. If you can do it with a conventional pig, if you've got a straight length of pipe, constant diameter, and you can put a conventional pig in, that is better than the ice pig. The problem is that there are very few straight lengths of pipe. When you've got the topology that you're likely to have in the factory, the ice pig looks brilliant. And there is breakthrough, and the only way that we can get to it is to find out what your product is and the topology that you're pushing the stuff through. So if you wanted numbers, we're sort of saying that for the yogurt video that you saw, the first one, I reckon you could have sold at least 75% of that to the punter, and there would have been absolutely no traces. If you were more, if you wanted to exaggerate, you could probably get up to 80 or so %, but it becomes iffy after that.
Joe, can I add as well that the thickness of the ice will have a huge impact on the amount of product you can recover, and the sharpness of the distinction between product and ice. and then the mixing in between. And what we can do now, which I don't think was possible at the time of these trials, and is only recently something that we've pioneered in the water industry, we can make some very, very thick ice. And the ice that you saw on the video there was quite wet. I think it was 75 to 80% ice fraction. Thick ice gives you a much sharper. It's exactly the same stuff, just with a higher ice content. A sharper distinction between product and ice, and should give you a stronger, a higher percentage of recoverable product. Although thick ice has its complications, and you have to be careful about pressure build up in the pipe, and then you start looking at other complications. But it is definitely something that is an option depending on the type of product and the type of pipe work that needs to be cleaned.
Hi everyone, this is Michael at Carbon Trust. Sorry about any technical difficulties there. I think I dropped off the call at my end and thought you'd all vanished. So hopefully my workaround by unmuting all of you worked. I missed the last 2 or 3 minutes of questions, so are there any more questions that we'd like to ask the group? You should all be unmuted now. No? Okay then, all that remains for me is to thank Joe, Andy and Matt for presenting today, and also Dairy UK for putting us in touch with all of you. We have recorded this webinar, though how that works with my technical difficulties remains to be seen. If it's worked well, I will make it available to everyone on our website, and hopefully circulate that through Dairy UK as well as possible. So thank you all very much for coming.
Thank you.
Thank you.
Thank you. Bye.
Bye.
You made a comment about the reduced temperature of the effluent being a benefit to the effluent.